have to know. So how does that relate to our programs that we have written so far? Okay, we have one program called ADT and the other program called no ADT. The program called ADT, which stands for Abstract Data Type, has one layer of abstraction. The main program is like a consumer. Okay? In other words, the main program says, I just need a way to represent the coordinate of a point. I don't care about the details. I just want a way so that I can remember, oh, this pixel is over there. Okay? And the abstraction layer is what we call the subroutine init coord xy. It provides an abstraction. In other words, it's hiding the details from main. Now, what kind of details are we hiding? It doesn't seem to be doing any type of detail hiding. You know, we give it x, we give it y, it initializes the x component to x, it initializes the y component to y. Why do I call this abstraction? Well, let's think about this. Let's think about, you know, in the case of no ADT. And let's just say this is not a simple program with only 11 lines. Let's think about this as a fairly large program for drawing something on the screen, and it has, let's say, 50,000 lines, which is considered a tiny little program in the commercial world. 50,000 lines. Of those 50,000 lines, there will be many, many occasions where I need to control the x and the y of a point, right? I mean, if the whole program's purpose is to display something on the screen, it will need to control the coordinate of x and y of many, many pixels. Okay? So let's just say that, you know, out of the 50,000 lines, we have 2,000 lines directly manipulating the x or the y of a point. Is that okay so far with that assumption? And let me just write it down too. So our assumption is this is a 50,000 line program, and of which, you know, 2,000 lines to access the x and y components directly, which seems somewhat reasonable. That's only about 25th of the size of the program has direct access to x and y. And one day your boss came along and say, hey, we need to change the program. Instead of using the xy coordinate, I want the program to use the polar coordinate. Okay, what is a polar coordinate? XY coordinate is fairly easy to understand. We have the x-axis, we have the y-axis. So a point is expressed by how far is it away from the 0 point in terms of x, how far is it away from the 0 point of y, and that's xy here. Is that okay? That's a very typical way of representing where a point is in 2 dimensions. Polar coordinate is saying, oh, we don't use x and y, we use a radius and an angle. In other words, what we do is we specify this is the point, and this is the origin, or the 0 point. And what we do is we measure the distance. We call it r for radius. And this is They should have a little scoreboard, next to the trash can. And I have a lot more markers. Okay, this is r and this is theta, and we can find any point that I can define any point in a 2 dimension by expressing the radius and theta. Is that making any sense? Now, the reason why I want to change my coordinate system from xy to a polar system can be many different reasons. Okay, a radar display has a polar coordinate because the radar itself is sweeping all the time, and it is only displaying the objects that are reflecting the pulse from the radar. But there are also other applications where the polar coordinate makes more sense. Okay, has anyone seen the bicycle? It's a bar. Okay, let me just show you. Better yet, let me just look for it on the internet so I can show you exactly what it is. And you can see what I'm talking about. Bike, I think it's a spoke light. That's it. And we can look at videos. This is a good one. And, oh, okay, it does load. Okay. This is a, I'm not sure whether you guys can see it. It's a bike, turned upside down. And someone had to spin the wheels, so that it is basically rotating. On one wheel, they have a light bar that has yellow LEDs, and on the other one, it has a light bar that has blue LEDs. And as the spoke rotates, a controller, basically a miniature computer, can control the LEDs to turn on and turn off. If you can precisely control, at which angle which LED can turn on and which LED can turn off, you can use the visual, because our eyes can only see things at about 22 frames per second. Anything that's refreshing faster than that, we see it as constantly on or constantly off. And you can use that to basically have an effect like this. Okay? So that means if you want to paint something using this particular way of painting something, you have to translate everything to a polar coordinate. In other words, you have to say, if I want the Pac-Man mouth to start at this point here, this is a certain distance away from the center of rotation and at a certain angle. Okay? And that's how you can specify the pixels. Or if you want to look at a ghost here and you want to say, okay, I want the eye to be off. Okay, there's no light to turn on for the eyes. So that means you have to specify that by how far is this pixel away from the center of the spokes, and what is the angle that I have to turn, at which angle should I turn off this LED? Keep it off until this point here, I will have to turn it on back on again. Okay? Does it make sense that sometimes we want to rely on polar coordinate instead of XY coordinate? Okay, this is just an example of why your boss might want to ask you to change your program. Okay, so now that we are convinced that sometimes we have to rely on polar coordinate instead of XY coordinate, let's go back and look at our two programs, the no ADT and the ADT one. First of all, we look at the no ADT program. It is a 50,000 line program, of which 2,000 lines directly access the X and the Y. But guess what? Your new program does not have an X and a Y anymore, because your data type here will now be changed to R is in radius, and then you have theta. And for our purposes, you can just look at it as a real number. Okay? In other words, of the all of these 2,000 lines would have to be changed. Are you guys convinced that when you have to change the record type from a XY coordinate system to a polar coordinate system, with the no ADT version of this program, you will have to change 2,000 lines so that they will, instead of referring to X and Y, they now refer to R and theta. And obviously the calculations will have to be performed on each and every of these 2,000 lines. Is that okay so far? That's tedious, okay? Finding these 2,000 lines to change is tedious. The next question is, okay, so this is an easy change, but then you will have to change all 2,000 lines to change the coordinate representation to polar. Okay? Now, what is this program buying me? 2,000 lines of direct access translates to about 1,000 lines of invocations to invoke coord XY, right? Because every two direct access to X and Y translates to one invocation to init coord XY. So this is again about 50,000 lines, and of which 1,000 lines invoke init coord xy. Okay, and you have to do the same changes as far as the type is concerned. We don't have x anymore, we have radius. We don't have y anymore, we have theta as an angle. Then what do? Do you have to make a new subroutine and change all 1,000 lines to call the new subroutine? No. We have to make 2 additional lines of changes and I'm done. Okay? The 2 additional lines that I have to change is just over here. I changed this line so that it now reads c.r gets the square root of x times x plus y times y. This is how I calculate the radius, okay, which is the, how do you call the diagonal line of a triangle? Hypothesis?
Hypotenuse.
Huh?
Hypotenuse.
Hypotenuse, okay. And that's how we compute it. It's the square root of the x squared plus the y squared. And the theta is not too hard to compute either, because that's arc tangent of, let's see, I think that'll be y divided by x. There are some special cases here, like if x is 0, then you have to use the other version. So you actually need like a conditional statement here to check for the special cases. But okay, let's say you have to specify 5 lines to replace these 2 lines. Okay? Do you have to change anything else? How about all these invocations to init coord xy? Do I have to change those? Not a single line. Because as far as the main program is concerned, it does not care how a coordinate is implemented. All it cares is, can I specify a coordinate based on the xy coordinate? Well, the subroutine called init coord xy gives me the ability to see everything as xy, even if the representation is changed. Okay? So that means with ADT, I only have to change, I don't have to change anything in main. Okay? To change 0 lines in main, just changes to the record type, and in this case we also have to change init coord xy. Okay, so now you tell me which one is better. Well, obviously the second one is better because you don't have to make nearly as many changes as the first one. You get paid by the hour. Well, in that case, if you're paid by the hour, I'm not sure about the hourly rate that you'll be paid, when your boss sees the program. What is minimum wage these days? That will be his question. That reminds me of a Dilbert, cartoon. Do you guys watch Dilbert or read Dilbert in the good old days? There was one episode of one, comic strip where the boss, the pointy hair guy, told Wally and said, well, for every buck that you catch, I'll pay you X amount of money. And then Wally turned around and say, I'm going to write myself a minivan. Do you guys understand what he's saying? Because, he can just artificially introduce as many bugs as he can and then claim that he's fixing all those bugs. And because his pay is based on the number of bugs, so he said, I'm going to write myself a minivan because he's just artificially going to write really buggy programs and then collect the money by fixing the bugs that he artificially introduced in the program. So it's the same way here because one